1 year ago, I was barely able to draw a triangle primitive to the screen, and now I have written and rewritten my own game engine, including graphics and texturing, physics simulation, I/O controls, as well as interesting techniques and optimizations used in games, and I will be going through my learning experiences, my failures and my successes, and my overall progression in this game engine that I've developed. I hope you enjoy it. So I didn't immediately start writing my game engine. Instead, I wrote a simpler 3D renderer that I needed for another project, which was a project where I would take a lot of images, do some image processing to them, and ultimately build a point cloud out of those images to represent an object. This is also available on my GitHub, you can check it out. And this really forced me to start learning OpenGL in C++ as my image processing pipeline was also in C++. All jokes aside though, this was extremely useful to me for this game engine, and I owe it all to one man on YouTube named Victor Gordon with his amazing OpenGL tutorial series, which take you from the Hello Triangle to a 3D pyramid where you can freely just fly around the pyramid, and it's a textured pyramid, and this will give you everything you need to kind of understand the very basics of 3D OpenGL development. This was one of the most difficult steps in my engine development journey, as I feel like OpenGL and graphics programming in general have a steeper learning curve than traditional CS topics. And so I really spent the next 6 months just mastering the basics of OpenGL by learning the general environment, such as the libraries like GLM that would do the heavy lifting with the matrix operations for the 3D graphics, as well as the platforms like MSVC, as well as CMake and Make on Linux, to develop, compile, and debug the application. Okay, so now I'm ready to make this game engine. So now I'm asking myself, how do I do this? How do the big titles do this? Well, they use stuff like LOD systems and culling techniques to essentially prune the triangles that aren't visible to the user. And for the ones that are, they get passed through a very complicated rendering system, including optional ray tracing, different materials and how those are rendered, multiple light sources, ambient occlusion, and in general, very complex systems that allow these AAA engines to look great and feel great.
Wait.
Yeah, so that ain't happening. But then I came to my senses, and I realized that Notch from Minecraft didn't recreate the Unity engine so he could build Minecraft. Instead, he built the game directly, and the engine naturally followed. This sounds trivial, but it was very hard for me to judge where the game ended and where the engine started. And I wanted to follow the high cohesion and low coupling design principle that you learn in your 4-year CS degree. For those who didn't do that, basically high cohesion is a module that doesn't do many things, but it does one particular thing, and the coupling is how all these particular modules actually interact with each other, and ideally we keep that to a minimal so that if we have to change one component in the system, the other components aren't affected as much. But in games, it's notoriously hard to do that because you're simulating one unified environment with rendering, physics, this, that, and all these components need to share the game's state, data, callbacks between components, and so they become really tightly dependent on each other. So for this reason, I pretty much just threw the software design principles out the window for now and just created this first implementation on an ad hoc basis, meaning just creating modules as necessary to basically build out my game. And what kind of game, you ask? Well, a racing game, of course, because I love Mario Kart Wii. Okay, so now I need some kind of controllable car that looks like a car, that respects physics, and that can drive around on a map, and now that I have these requirements, I can pick the tools, the libraries, and the general system that I need to build to essentially bring this into fruition. So I started off with a simple vehicle that can just kind of drive around on an invisible plane, and this took me a while to figure out. Thankfully, the Bullet Physics library actually did most of the heavy lifting for the physics simulation, but just to get it working was a hassle because some of these tutorials and these demos are almost a decade old. So after scouring the Bullet forums and their documentation, viewing some ancient forum posts, and a lot of trial and error, I managed to get a vehicle with decent controls that was also synced up with the rendering system, as well as a map loaded in in the physics simulation that wasn't just a flat plane. But as I tried a slightly bigger map, the FPS dropped harder than the beat.
Hey, the beat go off? Hey.
And this is where I introduced my first optimization, specifically optimizing the physics simulation. Just like the Minecraft chunking system, it would only load chunks near the player, as that's what the player would be most likely colliding with. So in my case, this chunk over here would never be colliding with the player. I utilized Bullet's terrain shape rigid body type, which essentially you input a 2D matrix of height floats, or integers, it doesn't matter, and it would just generate a height map object. And this was really nice because I could just draw out maps in Paint and then chunk them up and then put them in the game and then just dynamically load chunks near the player. So that's what I did, and it worked really well. At this point, I was very happy with the prototype, and so I kind of started with the shaders. I added like textures on the floor. I was messing around with the GLSL and kind of adding animations and like colors swapping and a bunch of weird stuff. But I realized that my code was just absolute garbage and I had to rewrite immediately. So last spring break, that's what I did. I rewrote the entire engine.
Damn!
Well, not everything, but I redesigned it in a much more modular way to kind of align with what I was talking about earlier with the software design principles, as well as taking heavy inspiration from other projects such as GTA 3 Rewrite, as well as using the latest C++ language features such as the shared and unique pointers that, enhance memory safety, as well as just making better tooling for myself. And I feel like I really leveled up as a game engine programmer. Building this project and kind of just messing around with it and seeing the capabilities, like I tried threading and then I messed around with the rendering, but then really re-engineering the project with maintainability and memory safety in mind. Along with the evolution of the game itself, my workflow has also evolved, using tools like Asan, which is a sanitization tool that checks for memory leaks, along with Perf, which is a profiler to see which functions in the game take a long time and might be slowing down the game. Now, I'm not going to claim that I'm good at this yet, but what I can say is what previously would take me months to do, I can now do in weeks. And although my game is far from completion, I feel like in the past couple of weeks, I've really been able to ramp up the progress and in general, write better code and better tooling for myself, along with just feeling much more comfortable in this C++ game engine stack. In the last couple of weeks, I was able to take my rewrite from this to this. And in the next video, I hope to show you guys something far greater. Thank you so much for watching. Thank you so much for the support you guys have been giving me, and I hope to see you in the next video.